Hello everyone, welcome back to Code Bits N Bytes, where we break the technology one bit at a time. First of all, sorry for the long break. Life got a little busy, but I'm back and I'm super excited because I have been planning not just this video, but a brand new series for this channel. So if you are into coding, problem solving, and learning how to think like a programmer, make sure you stick around. I was thinking, what should today's video be about? Should we start a step-by-step practical guide solving computer problems? Or maybe dive into soft versus hard programming and how problems have evolved with time? After some thought, I realized it makes sense to start with something really useful right away. Yes, a practical approach to solving computer problems. But before we dive in, I quickly want to share the motivation behind creating this channel. Even today, all the tutorials, courses, and coding resources available online, many students struggle with the basic thing: mastering problem solving skills. Back when I was doing my bachelor's, I made it my mission to improve this skill. Luckily, I got great professors who guided me throughout my journey. But I saw some students lost in the process. And as a teacher myself later, I realized something similar, that students are scared of programming. It's not because they can't do it, it's because they doubt themselves. That's why I have created this channel, Code Bits and Bytes, to share my journey, techniques, and practical tips so that we can build confidence in coding. Remember, problem solving is not something we can master in a day or in a video. It's a long journey, and I'm still learning it with the years of experience I have. So let's get back to today's video, a step-by-step practical guide solving coding problems. We'll walk through some computer problems and apply the techniques that we have already discussed in our earlier videos. The goal here is to train our brain to think like a programmer. Because at the end of a day, solving computer problem is just about breaking things down into simple and small steps that even a machine can understand. Let's use a simple analogy. Imagine asking a toddler to bring you a toy. The instructions that mommy might ask her: "Sweetie, please go straight to Papa's room where you play. Find your red ball on the floor near Papa's desk. Pick up the red ball with both hands. Be careful, the desk might hurt you. And finally, bring it to the mommy." And that's exactly how problem solving in programming works. We take a big problem, break it down into smaller, crystal clear steps, add the necessary checks, and put it all together into a complete solution. Once you understand the problem, the next step is to actually break it down into smaller, computer understandable instruction. Because at the end of a day, a computer cannot think like us. It can only perform three basic operations: a calculation, addition or multiplication, a logical operation, true or false, yes or no, and a memory access, storing or retrieval information. That's it. Every complex problem you'll ever see is built on top of these basic operations. In a practical approach today, we'll see how big problems can be reduced to the steps to fit into these basic building blocks. In today's video, we'll practice some of the coding problems. We'll start from something really basic, moving to a medium level challenge, and finally a little tricky. We'll assume you have a basic knowledge about loops and arrays. Our first problem is something very popular in programming exercises and coding interviews. Yes, a palindrome. So, for those who might not know what a palindrome is a word, sequence, or number that reads the same forward and backward. For example, Madam, Bob, Civic, or numbers like 121 or 1331. Let's take an example, the word Madam itself, and verify whether it's a palindrome. As we said, the word is the same, backward and forward. To verify it, let's break down the process step by step. So if we recall, we already discussed that computers can perform three basic operations: calculations, logical operations, and data retrieval or storage. So we'll break down the problem into smaller steps using these operations. Now think for a moment. We need to compare the word that reads the same from left to right and right to left. For those who are new to the programming language, a word is an array of characters in most programming languages. That means we can treat sequence of characters individually and compare each pair one by one. Look at the first character M and the last character M. They match. Move one step inward, compare A with A. They also match. Now check the middle character D. Since there is nothing left, we can safely assume a character is equal to itself. Since all pairs matched, Madam is a palindrome. Let's try and the method to check if Madam is a palindrome. Let's go to our definition where we define it. By recalling our definition, we can say a word, number, or sequence that reads the same in reverse order, so that we can compare characters one by one as we did previously, or reverse the entire input to compare it to the original. Intelligence, when reversed, becomes a different word, while Madam, when reversed, becomes the same. Note the capital M at the end to make the reversal more visible. We'll check this in the code as well. Let's try on a word that is not a palindrome. For example, intelligence. Start with the first letter I and compare it with the last letter E. They are not equal, so there is no need to continue the comparison, as the first condition failed and intelligence is not a palindrome. We'll convert our dry run into code and refactor later if needed. I've set up the editor and terminal. You can use any language or editor you like. Let's check whether Civic is a palindrome. If we recall, we started by comparing the first character with the last character. A word is an array of characters, and in most programming languages, the starting index of an array is 0. As we did in the dry run, at each step, we move forward one character from the start and backward one character from the end, until we reach at a point where start and end cross or meet. That means we compare while start is less than end, or we stop early if the comparison fails. Remember, if the character from the left is not equal to the character from right, there is no point continuing, as we saw in one of our previous example that was intelligence. If the characters from both sides are equal, we move forward with start and backward with end. For example, start equals to start plus 1 or start plus plus in some languages, and similarly end equals to n minus 1 or n minus minus. Coming back to our condition where start is less than end, after some iterations start may move ahead of end, which means all characters pairs have been compared. That's the point where the loop terminates. So our algorithm for checking palindrome is ready, except for one last detail. Inside the while loop, we are comparing characters and moving indices, but we also need to track whether any comparison fails. So we'll use a Boolean variable to store the result. Let's call it is palindrome. Set it to false when a mismatch occurs and break out the loop. Now let's print is palindrome for input Civic. It should be true. Perfect. It's working now. Now let's try some more examples that are not palindrome. Let's try with input hello. As hello is not palindrome, the function should return false. Awesome. So our algorithm is working for positive and negative cases. Now let's try with age cases. Before we check Civic, in sentence case, remember that capital C is not equal to lowercase c. So it should be false. Now there are different ways to ignore cases. We can convert the input to all uppercase or all lowercase, or convert case during each comparison. As we said, it's not palindrome. Now we need to change input to all lowercase, and this time it should return input as palindrome. Run it again. Awesome! It works for all the cases, and we have handled the edge case of case insensitive input. The approach I used was first a dry run, then pseudocode, then code, and finally edge case fixes. This approach consistently improves problem solving skills. You can use your own strategy to solve and improve algorithm efficiency. Comment out which way works for you. I'll upload all the code files to my GitHub account, linked here. There's an exercise for you. We discussed two ways to check for palindromes. Try implementing the reverse and compare method yourself, or find the code in my GitHub under the code Bits N Bytes repo.